Hello everyone. This video will be the continuation of the Truss problem what we discussed in video 3. So till in video 3 we had discussion on the element stiffness matrix for first element and second element, the element connectivity table, and even the boundary condition, how to find out all these values we had discussions. So before moving to this video, I suggest everyone to watch module 2 video 3, then it will be easy for you to continue the remaining part. So we have ended up our discussion in the video 3 till calculating the element stiffness matrix for element 2, and for the element 3 I'll be going with the same stiffness matrix equation, that is the formula will be A3 E3 by L3. So I know what is the length for the element 3, which is given in the question itself, which is root 2. A2 and D2 it is common, so 0.1 meter square and 17 to 10 power 9 Newton per meter square, and L value and M value, that is cos theta and sin theta value is given. So L and M value, if I am substituting, means finally I will be getting the keeping 10 power 9 outside, means I am getting 7 by 2 root 2 inside. So all these things I will be getting, and if you are if you are feeling very difficult to remember the locations, means no problem. For the element 1, I know that what is the initial node and what is the final node. So first two digits you write the initial node, second two digits you write the final node. So for the element 1, hope you remember, node 1 is the initial node, node 2 is the final node. So for initial node, what is the displacement? It is D1 D2. For node 2, what is the displacement? It is D3 D4. So D1 D2 D3 D4. Here also you can write D1 D2 D3 D4. Similarly for element 2 also we have two nodes, that is node 1 and node 3. In this I have taken node 1 as the initial one and node 3 as the final node. So answer like the location will be D1 D2 D5 D6. So D1 D2 D5 D6. So like this we can write even for all the three element stiffness matrix. So far we have stiffness matrix of each element in global coordinate system. Now the next question will be how to assemble them. We know that we have three nodes in the given structures and each node is having 2 degrees of freedom. So therefore the stiffness matrix of structure should be of 6 cross 6 matrix. So see, you can able to see here in the continuous order I will be writing, that is node 1, node 2, node 3 order I will be writing in both upper side and even the like the left hand side. So node 1, node 2, node 3. So D1, D2, D3, D4, D5, D6. I have written a 6 cross 6 matrix. You can able to see here. And now I will be assembling. So what is the first location? It is D1 and D1. What is the second location? D1, D2. Third location D1, D3. Fourth location D1, D4. Fifth location D1, D5. Sixth location D1, D6. So like this I will be adding up everything. So in this video you can able to see, let me add up, this is element 1, element 2, element 3, element stiffness matrix. How I will be adding, let me see this. So to avoid the confusion I have written, see, green color indicates node 1, blue color indicates node 2, and brown color indicates node 3. So wherever this location is there, that we need to add up. See, the first location it is D1 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 D2, next D2 D1 and D2 D2. So this is the same condition. So as it is we can write it. You can able to see here as it is I have written. And similarly second condition is nothing but what? Green and blue. So this is green and this is blue. So what will be the answer? Minus 7000, minus 7000. So likewise the color wise you can write it, or else D1 D2 D3 D4, even that order wise also we can write it. So everywhere we have to write this one. And the final structure stiffness matrix we will get something like this: 7 7 7 plus 7 by 2 root 2, 7 by 2 root 2, 7 by 2 root 2, 7 plus 7 by 2, 7 by 2 root 2, and it is basically a symmetric matrix. You can able to see here the first row values and the first column values should be same. If you take any row and any column, the values should be remain same in the corresponding locations. 10 power 9 commonly I am getting outside. Now applying the boundary condition. So what is the boundary condition? Have you look on the given sketch. First let me start with the node 1. Node 1 it is fixed support. So both x and y it is fixed, that is D1 and D2 is fixed. So you can able to see here first row first column, second row second column. Moving to the node 2, nothing is fixed here. So both D3 and D4 it is free. So you can able to see D3 and D4. Next one you can able to see here at node 3 it is fixed in this axis, and in this axis it is free. So D5, that is x-axis it is fixed and y-axis it is free. So D5 is fixed. So what is left out means 10 power 9 into these values inside the matrix, whatever is not eliminated, that one will be our condensed global matrix. Next is force. The same rules we can follow after eliminating these things, and only at this point only we will be getting. So since the force is acting towards downwards, we have to put negative direction and the magnitude is 1000. So minus 1000 force I will be writing. So I will be finding out the unknown displacement, that is D3, D4, D6, or U3, U4, U6, or Q3, Q4, Q6. Either you can use a calculator or directly you can solve it, and finally this is the answer you will be getting. I suggest all the students to solve this problem manually. So directly do not depend on these videos. Even you start you calculate the problems in your notebook. Try to avoid watching the videos when you are solving it. You watch it once or twice continuously, and later without watching the video try to solve it. So the values I am getting as at D3 as minus 1.429 to 10 power minus 7, D4 is minus 6.898 into 10 power minus 7, and D6 is minus 1.429 into 10 power minus 7. Moving to the stress calculation, sigma, like we have three elements, so for all three elements individually we need to calculate. The formula is Young's modulus into B into T into D. So D again is nothing but the displacement matrix. For element 1, which is the initial node and final node, corresponding you write that one, and remaining is LM0000 LM. For the each element, what is L and M value, that corresponding value you substitute. So here I will be getting the sigma 1 as minus 10003 Pascal, sigma 2 is minus 10003 Pascal, and sigma 3 is minus 14140 Pascal. So this is the stress value I am getting. So this is a problem I am giving you as a homework. Everyone do try this problem, and if possible submit your answers as a assignment in your Google Classrooms. So with this the problem is completed. Any doubt in this problem? Let me know first. See, answer is given for this particular problem. The deflection value, find the magnitude direction of the deflection of the joint C. So this value only they have asked us, that is the U value, which is 23.4 mm, and the direction is 9.8 degree to left of vertical. So it's your duty to find out how this value you are getting. Step by step you need to solve it. It is not very tough, it is easy only. And this particular problem reaction is not asked. In case the reaction is asked means we know, like the equilibrium equation K into Q minus F, which is equal to R. So wherever the nodes are fixed, only find out the values at that particular locations, so that you will get the reactions. And in case in the same problem, if they are asking you to calculate the strain, means from the stress value just divide with the Young's modulus, corresponding Young's modulus value. Whatever the number you are getting, that will be your element strain value. Yes, with this video gets completed. Thank you.